Let's take a look at absolute value equations. So hopefully you remember the basic definition of absolute value in general, and that's it. If you have an absolute value, it's the distance from zero on the number line. So if you have a positive number, it stays the same. And if you have a negative number, it's the distance from zero. So distance is always positive. It changes that number into a positive. So the definition is that the absolute value of x is just x if x is greater than or equal to 0. Okay, so that says if it's positive or 0, we don't do anything. And if it's negative, we have to make it positive, so that means we use negative x. Okay, so we don't do anything if it's already positive, and if it's negative, we put a negative out front to make it positive. So this definition tells us what we're going to do in order to solve equations. So let's say that we have something like absolute value of x equals 5. Okay, so what kind of solutions could I have in here? Well, obviously if I put 5 in here, absolute value of 5 is 5, so x could be 5. But x could also be negative 5. Okay, because if I put negative 5 in here, that would also come out, when I take the absolute value, that would come out to be positive 5. So I have two possible solutions for almost every absolute value equation. And in order to solve this, we think of this, so we're looking at this as just x, where we can figure out the numbers, but this could be any expression in x. Whatever's inside that absolute value either has to be 5, or it has to be negative 5, so when we take the absolute value, it still comes out to be 5. Okay, so if we wanted to solve an absolute value, let's say we had 4x minus 2 equals 18. Okay, so the absolute value is 18. So that means that what's on the inside is either 18 or what's on the inside is negative 18. So that gives us two different equations to solve. Either what's on the inside is 18 or what's on the inside is negative 18. And then when we take the absolute value, it comes out to be positive 18. Okay, so every absolute value problem is going to break up into two possibilities here. So solving the left one, I want to get x by itself. So I'm going to add 2 to both sides. I get 4x equals 20. And then I want to do the opposite. So I'm going to divide by 4. And I'm going to get that x is equal to 5. And you should be able to come back up here and check in the original equation. 4 times 5 minus 2, that'd be 20 minus 2, and that is 18. Okay, so that one's good. Solution. Okay, and now we solve the other one. It's going to be the same steps, just slightly different numbers. So again, I'm going to add 2. My pen's lagging a little bit. Okay, so we're going to get negative 16, and then we divide by 4, and that's going to give us 16 over 4 is 4, and it's going to come out negative. So negative 4. Okay, now this one might be a little bit harder to check in your head, but you should be able to, if you can't do it in your head, you can write it down. 4 times negative 4 would be negative 16. Negative 16 and negative 2 would be negative 18. And then when we take the absolute value, it comes out to be positive 18. Okay, so that one checks as well. All right, so you see we get two answers, and they both work. Okay, let's try another one. Let's say we have 3x minus 1 plus 4 equals 10. Okay, so for this one, okay, this one over here and this one over here, they were both in the form absolute value of something equals a number. This one is not, okay? Just because there's an absolute value in there doesn't mean that I can break this up, because this doesn't mean that the left side is positive 10 or negative 10. It doesn't work that way because of this plus 4. So what I need to do is I need to get the absolute value by itself so that I can break it up. So my first step is to subtract 4. And I get 3x minus 1 equals 6. Okay, so now I have absolute value equals a number. Now I know that what's on the inside either has to be positive 6 or negative 6. So now I can solve this. But that first step, look at that first step. That's very, very important. You have to do that first. Okay, so now I've got 3x minus 1 equals 6. That's the positive version. And I've got 3x minus 1 equals negative 6. okay? Because what's on the inside either has to be 6 or negative 6. Okay, so solving the left-hand side, we're going to add 1 to both sides. We get 3x equals 7. Okay, then I want to do the opposite. I'm going to divide by 3, and I get x equals 7/3. Okay, so there's one answer. We can come back up and check. The 3's are going to cancel. 7 minus 1 is 6. 6 plus 4 is 10. That works. You can write it out if you need to. And then solving this one, we're going to add 1 to both sides. And we're going to get 3x is negative 5. Divide by 3. And we get x is equal to negative 5/3. Okay, and we can check that one as well. It's going to come out to be, this will be negative 6, that's positive 6, 6 and 4 is 10. Okay, the 3's will cancel. It looks kind of messy, but the 3's will cancel when you plug it in. Okay, so that's the idea there. Let's hop back over here and do one more. I'm actually going to erase this so I don't get an error. Okay. All right, last one is a little bit different format. Okay, and this might seem a whole lot more complicated, but really it boils down to the same idea. You've got the positive version and you've got the negative version. Okay, so there's actually 4 different combinations of positive and negative, but it comes down all 4 versions are basically 2 versions, either their same sign, which is positive, or opposite sign, and it doesn't matter where you put the negative. Okay, so let's see how that works. All right, so the positive version would be just exactly how it's written. Okay, and then the negative version, see how over here on each one we had a positive version and a negative version. So the negative version, you've got to put a negative on one side, and it turns out it doesn't really matter which side you put it on. Just make sure that you put it on one side. Okay, and you want to make sure that you use parentheses because we want to put a negative around the whole side. I'm going to redo this because those kind of look like parentheses, and they're not. They're absolute value bars. Okay. All right, so even if you have variables on both sides, it still works the same way. You've got the positive version and you've got the negative version. See how I put a negative out front there? Okay, and it doesn't matter which side you put the negative on, just put it on one side. Okay, so now we've got 2 versions to solve again. So solving the left side, so this time I've got x's on both sides. So I need to get the x's together before I can try to get them by themselves. So let's subtract x from both sides. So I've got 5 equals, this is going to be 1x, or just x. Now I can get x by itself, so I'm going to add 7, and I'm going to get that x is 12. Okay, so there's one solution, and again, you can check it. 12 and 5 is 17. 24 minus 7 is also, wait, 17. 24, yeah, 24 minus 7 would also be 17. Sorry, a little bit of a brain flub there. So that one also checks. This one is going to work very, very similar to this one, but the first thing we've got to do is distribute that negative. So the left side stays the same. We're going to get negative 2x. And then when we distribute the negative here, negative, negative, this is going to come out to be positive 7. Okay, so let's put the x's together again. So we're going to get 3x plus 5 equals 7. We want to get x by itself now, so we're going to subtract 5. We get 3x equals 2, and I'm going to have to just squeeze this in here. Do the opposite. So we divide by 3, and we're going to give myself a little bit more room here. And we get that x is equal to 2/3. Okay, so there's our 2 solutions for that. So notice each of these has 2 solutions. The solutions aren't necessarily positive, negative. You can see here both of these are positive, but you're going to have one solution for the positive version and one solution for the negative version. Okay, so for almost all of these, you should end up with 2 different solutions.